In today's lesson, we're going to talk about how to perform a linear regression on your calculator, how to calculate a trend line by hand, and how to do some linear modeling of data. So many industries, almost all industries, collect data of some sort, whether it's demographic information of customers or locations or medical data or financial data or any other type of information. And companies use this to make predictions, to create mathematical models, to do forecasting. So often people ask how different variables, how different types of data is related. So if I look at what is known as a correlation is just a statistical measure that attempts to determine the strength between two variables and how one changes with respect to the other. Now, after you collect a lot of data, you can create what is known as a scatter plot. A scatter plot is just made by plotting all the different sets of ordered pairs. And we can kind of investigate these scatter plots and get a sense of how the different variables are related. So if I am looking at a scatter plot that looks like this first example, we would say that this has a positive correlation because we notice that the data is trending upward from left to right. So if you were to squint, it almost looks like a line that has a positive slope. So we would consider that scatter plot representative of positive correlation. In the second example, again, we could squint our eyes and we can see that the data is representative of something that is known as a negative correlation. So as the x variable gets larger, the y variable goes down, gets smaller. And if I have a scatter plot where there's just points all over the place and I see no trend, this would be known as no correlation. So there's different types of correlations. And there's actually a variable that allows us to calculate what is known as the correlation coefficient. It is representative by the letter R. And this correlation coefficient kind of measures the dependency relationship, the correlation between those two variables. Now, I should point out that the correlation coefficient is always going to be a value in between and including -1 and 1. So you're never going to get an R value, a correlation coefficient that is smaller than -1 or larger than 1. And the closer that this correlation coefficient R is to 1, the less that the points are scattered and the stronger the relationship. So if I get R equal 1, the correlation coefficient equaling 1, that is total positive correlation. If the correlation coefficient is 0, and not 0 point something, but 0, there is no correlation. If the R value, the correlation coefficient is -1, that is total negative correlation. And you can see here there is no correlation. The correlation coefficient is 0. And as it gets stronger positive, until it's in a line and it's exactly 1, then you can kind of get a sense on how strongly related the two variables are. Similarly, to the left with a lower R value, we have negative, stronger negative, total negative correlation. So the closer to 1, the stronger either positive or negative correlation. Now, we see that we can create a scatter plot, and from that scatter plot, we can create what is known as a trend line. So I can get an idea of the trend. I can get an idea of where the data is going, how it's going to firm up if I'm modeling something. Now, trend lines, well, there's many different ways to obtain or draw a trend line. One way is to draw a trend line where, let's say, half of the data points are above the trend line and half are below. Another way is to pick 2 points, calculate the slope of the equation, and then you get an actual trend line in a corresponding equation. So you can kind of just pick 2 points and say, hey, this looks like it's a good fit. Or I literally can take a piece of spaghetti and put it on my graph and eyeball it and say, this looks like it fits the data pretty well. Now, trend lines are not unique. There are many trend lines. There are many trend lines. They are not unique. However, there is only one unique line of best fit. You don't use the word best if there's more than one. So the line of best fit is unique, and it is the function, the linear function that best fits the data. Now, how do we get that line of best fit? Well, if you take statistics, you can learn more about how you can compute this using least squares and residuals, and how we actually obtain that correlation coefficient, or R. But the calculator knows how to perform a linear regression to get you that equation, to get you that unique line of best fit. You, again, find the line of best fit by performing what is known as a linear regression. So, you can actually do this on the calculator, and we've included some instructions, calculator instructions, on how to obtain that. So that is located online. We will go through that in class if you have questions. There is an example here that allows you to enter what is known as lists. So maybe I would put this as a list, maybe list 1, maybe list 2, list 3. It doesn't matter what you call these lists, but there's ways to enter lists into the calculator and find the linear regression model. So what you could do to find a trend line is to make a scatter plot. So here I have a scatter plot. And I can see on this scatter plot that my horizontal axis is perhaps Albany's temperature. And then on my vertical axis, my Y, my output, that would be representing Sydney's temperatures. So they're pretty aligned in different ways. And so you can investigate the scatter plot, and to pick a trend line, I could just pick any 2 points. You know, I could like maybe pick this point and this point, and then I could take a straight edge and draw a line. This would be a trend line because I kind of eyeballed it. And I could get the equation of the trend line by calculating the slope between these 2 points, and then using the slope and any one of those points and substituting into the point slope formula, and I could get an equation of this trend line. But to perform, to get the line of best fit, I would have to calculate, perform a linear regression. Now, this was an example we could do to investigate this a little bit further. We could ask people to fill in their shoe size, the height, the number of pairs of shoes owned, and we could look at these types of questions. So you will be asked to be able to take data, enter in lists, perform a linear regression depending on the variables that are chosen. So I could maybe say height versus shoe size, or later I could do shoe size versus number of pairs owned. So you have to be able to switch back and forth between which you're entering in as X, your independent variable, and which you're entering in as Y as a dependent variable. You'll have to perform a linear regression to get the regression equation. It will give you the correlation coefficient R. And then you'll have to talk about what that means in terms of the real world problem. What can you say based on this linear regression model? What does the y-intercept tell you? What does the correlation coefficient tell you in terms of whether it's a strong positive, weak positive, no correlation? What type of correlation is there? And then perhaps answer some questions and do a little bit of investigation using that equation, that regression equation, that model, to make a prediction. So these are the types of problems that you would be asked to complete. There is a worksheet, so you should make sure that you actually do this worksheet and turn it in. The key will be posted online after the due date. So make sure that you do these problems. So you'll have to estimate values of correlation coefficients.